Alright, welcome back to Mathematics Lifeline. In today's video, I want to explain to you how we can prove the product rule for derivatives using the definition of a derivative. Now, the product rule, you've probably seen this before if you're in calculus. It's the derivative of f of x times g of x is equal to f of x times g prime of x plus g of x times f prime of x. Now, of course, you've probably seen this and you've probably known it and you've learned it, but a lot of times professors are going to ask you to prove it. And this might be, one of your first proofs that you ever see, right? Because you don't really prove stuff like this in high school. But we're basically going to use the definition of derivative, which is written right here. So the limit as h goes to 0 of f of x plus h minus f of x over h is equal to f prime of x, or the derivative of f with respect to x. So we're going to use the derivative. Now, typically when we do this definition, right, we use f of x, but we have two functions now. We have f of x times g of x. So when we go to write this limit, we're instead of just writing f of x plus h, we're going to make the whole thing x plus h. So every x is going to change to an x plus h. So we still have the limit as h goes to 0, but now instead of just f of x plus h, we're going to have f of x plus h times g of x plus h. And now the next step is minus f of x, which in this case is going to be f of x g of x, because that's our original function. What I'm going to do is I'm going to leave a little bit of space, and you'll see why, because we're going to have to manipulate this just a little bit. But we're going to do minus f of x g of x right here. And again, all of this is over h. Now, the reason I left that space is because we're going to do something where we add and subtract the same term. And the reason is because when we have something like this, there's nothing we can do to manipulate it to get to this form as it is. So we need to go ahead and manipulate it just a little bit so that we can work with it and be able to, get to this form that we need. So what we're going to do is we're going to first subtract this term. It's going to be f of x plus h times g of x. And then we're going to add it back because we subtracted it. So the same thing, f of x plus h times g of x. I know it's a little small, but that's f of x plus h times g of x, and we subtracted it and added it. And now the reason that we're doing that is now we're going to break up this fraction. So we still have the limit as h goes to 0. And now we're going to break up the fraction right here. We're basically going to cut it right there. And you'll see why we do that here in just a second. So we're going to have f of x plus h, g of x plus h, minus f of x plus h, g of x, over h. And that's going to be added to the other part of the fraction, because we can split this fraction because the denominator is just one term. So now we're going to have the rest of it, which is f of x plus h, g of x, minus f of x, g of x. And all of this is over h as well. So now that we've done this, what we're going to do is we're going to manipulate these fractions that we have. So we see that in this left fraction, we have a common term of f of x plus h in both terms in the numerator. So we're able to factor out that f of x plus h. So we're going to go ahead and rewrite everything. So now we have the limit as h goes to 0 of, now we're going to factor f of x plus h out. And what we have left over inside is g of x plus h minus g of x. And all of this is over h. And now because we're adding two fractions in the limit, we're going to just go ahead and add another limit. Now this is plus the limit as h goes to 0. And this is okay because the limit laws say we can break up the limit into a sum of two limits. Now this one, we have a common term of g of x in both of the terms in the numerator. So we're going to factor a g of x out. So we have g of x multiplied by what's left over, which is going to be f of x plus h minus f of x. And all of this is over h. Now what's nice about this is we can use more limit laws for this, okay? Because now we have a product in the limit. So what we can actually do is go ahead and split these limits up. So we're actually going to go ahead and split this up into the limit as h goes to 0. Now this one we have an f of x plus h multiplied by this whole term. But what we can do is just put f of x plus h in its own limit and then multiply it by the limit as h goes to 0 of what's left over, which is g of x plus h minus g of x over h. Now this is okay because limit laws say that the product of two limits is the same as the product of the insides of the limits, right? Under the same limit. So this right here is the same as this term right here, just by using limit laws. And we're going to do something similar with this side. So we're still adding, and we have the limit as h goes to 0. But now we have a g of x multiplied by everything here. So we're going to put the g of x in a separate limit, and then we're going to multiply it by another limit as h goes to 0. And now we're going to use everything that's left over. So that's f of x plus h minus f of x all over h. So now that we've split this up into 4 different limits, right? And it looks a little complex, but this is all legal with limit laws. The nice thing about this is now our proof is practically complete. Now we just need to evaluate the limits, right? So here we have the limit as h goes to 0 of f of x plus h. Well, all we're going to do is plug in the 0, right? And that h goes to 0, so this is just going to go to f of x. So we have that, and we know it's being multiplied by the limit as h goes to 0 of g of x plus h minus g of x over h. Now you might think, what can we do with this? But remember the definition of derivative. The definition of derivative is f of x plus h minus f of x over h. This is in the exact form of the definition of derivative, just with g of x. So all this is the derivative of g of x just by using the definition. So this is g prime of x. And this is great because that's exactly what we were looking for, f of x times g prime of x. And now we're going to add the limit as h goes to 0 of g of x. Well, there's not even an h in this term. So this limit doesn't even matter. We're just left with g of x, and we're multiplying that by the limit as h goes to 0 of f of x plus h minus f of x over h. And that is exactly the definition of f prime of x. So we're multiplying by f prime of x. And that's it. We can go ahead and condense this a little bit into f of x times g prime of x plus g of x times f prime of x. And that is exactly the product rule for derivatives. So we have completed our proof of the product rule. So yeah, that's about it for this video. I really hope you enjoyed it. I hope this helped you. I'm surprised to see how many people are encountering these types of questions to prove this product rule, because really this is more of an analysis topic. Early analysis, albeit, but still, this is a tough question, and knowing this trick by subtracting and adding the same term is where it gets tricky. But everything else is pretty straightforward, I think, and I think it's a really great proof. Of course, the product rule is so useful in calculus, so having this is even better. But I hope this helped you, and if you have any questions, please feel free to let me know. But if not, then I will see you next time. Thanks for watching.